This is now the part C of question number 2, right? Here we have to derive expressions for the forces acting on the two moons. After we have the expression of forces on the two moons, we get a better picture how much exactly the forces are, and we will be in a better condition, better situation to compare the forces. So I'll try to find the expression of the total force on moon A and moon B. And everything is based on the same fact that force of attraction between two bodies having masses m1, m2 is given by the Newton's laws of gravitation, g m1 m2 upon r square. So that is the basic. So whatever I am going to derive is based on the basic fact. Two bodies m1, m2 separated by distance r. The force of attraction is g m1 m2 upon r. Everything is based on this fact here. So now let's try to find out the force on moon A. So this is the moon A here. This is moon A here. There are two forces acting on the moon, both in this direction. The force of attraction due to the moon B and the force of attraction due to the planet P. Okay. Now FB is equal to the force of attraction between the moon A and the moon B, okay, is capital G, mass of moon A, that is m naught, mass of the moon B, that is m naught again, upon the separation between the two. The separation between the two is RA minus RB, right? RA minus RB. So I can write here RB minus RB whole square. This thing. This is the force with which the moon B is pulling the moon A. Okay. Now let's find out the force with which the planet is pulling the moon A. FP here is again G. Mass of moon A is m naught. Mass of the planet is mp upon the separation between moon A and the planet is RA. So RA square. So the total force on the moon A is this plus this because they are acting in the same direction. I can say this direction is positive. Okay? Let's say this is positive direction, this is the negative direction. So both of the forces are in the same direction. The F net F C net is the sum of the two force vectors. They are in the same direction. This plus this. I can write it as G m naught square upon RB minus RB whole square plus G m naught MP upon RB whole square. This is the total force on the moon A due to the moon B and the planet. Okay, both of them pulling moon A in that direction. Moon B is being acted by the two forces in two different directions. It is being pulled in this direction by the planet and in this direction by moon A. The moon A, this is moon B I am talking about. The planet will be pulling moon B with the force G. Mass of moon B is m naught. Mass of the planet is mp. Okay. This is the force with which the planet is pulling the moon B. G, mass of moon B, mass of planet upon the separation between B and planet is RP. So RP square here, right? And again, we know that moon A with whatever force moon A is pulling B, with the same force B must be pulling A. So this is straight away, this thing only. G m naught square upon RA minus RB whole square. G m naught upon the separation square. So the net force is going to be the difference of the two, right? Let's suppose, I suppose that this force is more. It need not be, but let's suppose this force is more. Okay. So the F net on the moon B is this minus this. Okay. So G m naught mp upon rb square minus G m naught square upon RA minus RB whole square. So this is the net force on the moon B. This is the net force on the moon A. We have the expression in terms of the given variables m naught, mp, RA, RB, and the universal gravitational constant capital G. I have the expression. The net force of Fa, the net force exerted on the moon B.